Hi everyone, in this video we're going to look at kinematics, which is an application of calculus most closely linked to physics. So here we have a couple of definitions that we can call velocity as the change in distance with respect to the change in time, and likewise we can call acceleration the change in velocity with respect to the change in time. So we've got a little table down here that sort of summarizes all of that. So if we have a function for distance, we can differentiate it to find a function for velocity, and likewise we can differentiate that to find a function for acceleration. And working backwards, integrating a function of acceleration gives us a velocity, and integrating velocity gives us the distance. So and one little note I'll make here is that we use s for distance, because if we didn't, we'd end up writing dd all the time, which kind of can get confusing about what you're meaning there. Okay, so let's look at some examples here. So example 1 tells us that the distance travelled by a particle is given by this formula, and we're asked to find an expression for the velocity. So if we look at our table here, to get velocity we need to differentiate distance. So for question A, velocity is going to equal change in distance with respect to time, and so that means we're differentiating this function, so that would be 80 minus 24t. And it says hence find the initial velocity. Well, initial velocity will be when t equals 0, and so we put 0 in for t, and so 80 would be our initial velocity, and our units are meters, and time I'm guessing is in seconds, so I would say meters per second. Okay, so that's question A, and for question B it's asking us to find when the particle is at rest. Well, it will be at rest when its velocity is equal to 0, so we'd write 0 equals 80 minus 24t, and solve that equation for t. So 24t equals 80, and so t equals 80 divided by 24, and 80 divided by 24, we'll just do that, is 3.33 meters, sorry, not meters, seconds. Okay, so that's 3.3 seconds after our particle has taken off. Okay, question C is asking us to find the acceleration. So back to our table, acceleration is the derivative of velocity, and so we can write A equals dv by dt, so we're just differentiating this function, so we get negative 24, and that would be meters per second per second. So it's a constant deceleration. Okay, let's look at one more example, and then I'll let you have a go at some of your own. So a mechanical rabbit, i.e. the one that is used in greyhound racing, moves in a straight line. Its distance from the origin is given by this function. Which of the following is false? The rabbit slows down in the first second. Well, let's have a look. If we're talking about slowing down, we need to look at the velocity, and so we need to go v equals ds by dt, and that's going to be 6 minus 3t. Now we can see here that its initial velocity will be 6, and after a second its velocity will be 3, so that means that A is true. B, the initial velocity of the rabbit is 6 meters per second east, so just check, initially moving east, yep, so that one's true. The velocity of the rabbit at t equals 1 is 3 meters per second east, yes, that's correct as well. And the acceleration of the rabbit, so for acceleration we'd need to find the change in velocity with respect to time, and so that's going to be negative 3, and so the acceleration of the rabbit being 6 meters to the west, well no, it's actually 3 meters per second to the west, so D is the one that is incorrect. Okay, so hopefully that's illustrated how you can use differentiation to solve kinematics problems, and for some of you it'll be intuitive based on what you know about physics already, which is useful. But I'll get you to do 23.02, please. Thank you.